Meadows the other day. Play there ever?
Yeah, that's where we have practice.
Yeah?
Yeah.
That's a nice course. It's pretty easy, but it's a nice course.
Yeah.
All right, what are we doing tonight?
I don't have any work to do because we're just reviewing unit circle again. So can we just do ACT stuff?
Sure. Let's see, page 449, number 15 was the last one we did. 449, number 15, which would have been that top one. And notice, once again, it's hard for me when I see problems like 15, the very first thing that comes to my mind is back solve.
Yeah.
It's what I call an age problem or a marble problem. It's where, you have 3 more marbles than Bill, and Bill has 4 times as many marbles as Gene. How many marbles do you have? If questions like that, because you can answer them so easily with back solve. All right, let's look at 16. Geometry is always good to review when you're studying ACT because most people like you, it's been a couple years since you've had geometry. So It tends to be the toughest part for juniors and seniors taking the ACT. All right, so PQ and ST are parallel.
Yeah. So T would be 65.
Yeah, that's an interesting problem. It looks like it would be a lot harder than it is, doesn't it?
Yeah.
Is all you have to do is recognize that you have 2 parallel lines and a transversal, and that makes that angle the same as that, and we really don't care what this angle is. Another case where they give you information you really don't need, that's irrelevant. Let me bring up hold on a second. Let me put this up here, and get it out of the way so you can still read it. So how much money did Carrie have before she earned $3? Mitch, you still with me? Yeah. Okay.
Yeah.
Sure, I've lost
D
you.
minus 7.
Okay. And after she earns $3, what does she have?
D minus 4.
Good. Notice that they don't give you what you would expect. In other words, what we were looking for is D minus 7 plus 3. So we have to remove the parentheses and simplify ourselves. Basic algebra. How do I solve that? Manually, let's just refresh our solving algebra problems.
Wouldn't it be you have to move 1.8 to the other side and then,
Okay.
or actually, no, it'd be.
No, you're right to reconsider that, because wouldn't you be dealing in positive numbers? More likely, if you bring the 2.2 from the other side,
Yeah.
and then move the 0.2a to the right side. And then you have nothing but positive numbers. So if we do both of those steps at once, what do we end up with on the left? What's 1.8 plus 2.2?
4.0 equals
How many?
0.8a.
A equals what?
Equal.
You can use your calculator, but you really shouldn't need to. What's 40 divided by 8?
5.
And notice that that's the same answer as 4 divided by 0.8.
Yeah.
In other words, 40 divided by 8 has to be equal to 4.0 divided by 0.8. And once you recognize that, then it's an easy thing to do without the calculator. About 19. Now, how are you going to solve this? What technique? You're going to use algebra? You're going to back solve it? You're going to pick numbers and then back solve it?
I might just plug in the answers for.
Exactly. That's back solving it. Where are you going to start? Which number? You're going to start at 6?
Yeah.
No. Look at the thing. Which is the smallest integer? If you do 6, it may work. It may produce a negative number, but we don't know if it's going to be the smallest integer. So if we're going to back solve it, we want to start with the smallest and work our way up. So is 2 the correct answer? Well, square root of 8 plus 2, is that positive or negative?
That'd be negative.
That's the answer.
Okay.
You see why we'd start with 2? Because notice that if I start with 6, well, that's positive. But even if it were negative, I wouldn't know if that was the right answer or not. I would have to try 5 and 4 and 3 and 2, because it's asking for which is the smallest integer that satisfies that. So we're always going to test, as long as we're back solving it, we're always going to start with the smallest and work our way up. If it would have said, what's the biggest integer? Then I would have started at 6 and worked my way down. About 20. How are we going to solve 20? Algebraically or back solving it?
I'm doing it more algebraically.
Okay. How are you doing it? The problem with algebraic solutions is it requires you to formulate it perfectly. Which is fine. So what's your algebraic equation going to look like?
Actually, I don't know. The way I was doing it just completely just screwed me up.
Well, what's the length of the smaller piece? X.
Yeah.
X equals smaller. What's the length of the larger piece?
Y.
Well, it's 30 inches long, so how about 30 minus X? Right? And then we don't have to introduce a second variable. Now what can I say? X is to 30 minus X as what is to what?
3 is to 2.
Hold on a second. Yeah. X is to 30 minus X. That's the smaller versus the ratio of the smaller to the larger. And that is 2 over 3.
2 over 3, yeah.
Okay, and now how do we solve this?
Cross multiply.
So we got 3x equals 60 minus 2x. Next?
It'd be x equals 60. What?
5x equals 60.
Oh, 5x.
So x would equal 60 divided by 5. You should memorize.
Yeah, right. Yeah.
How many hours are there in a day?
12.
12.
It would be.
So what's the length of the longer piece?
18.
Right. Now that was a lot of math to go through. Let's take a different approach. Let's not do it algebraically. That was hard to do it algebraically. You couldn't miss a single step. But let's just start with the second smallest number. Now, in this case, we probably, whenever you're going to back solve something, and you know that when you try a number, you're going to know whether it's too small or too large, then you want to start with either the second smallest or the second biggest. So let's start with this doesn't even make sense to start with, right? Because if this were the longer piece, that would mean the shorter piece would be 24 inches. Well, we're definitely not going to start with G. In fact, we know that F is not correct, G is not correct, H can't even be correct. In fact, we might start with J. If the longer piece is 15, well, the shorter piece would also be 15, and that's not a 3:2 ratio. So what's the answer without even trying? 18.
Okay.
Because if 18 is the larger piece, that means 12 is the smaller piece, and that is indeed a ratio of 2 to 3. So it's actually much easier to solve these kind of problems using back solving. Do you agree?
Yeah.
I mean, compared to that algebraic solution, I had to formulate that and everything. So you want to get used to the concept of using back solving when you take the ACT. It will save you in a lot of situations. In fact, when I'm going through ACT questions, that's the first thing I look for. Is, can I back solve this? Is this a good problem to try to back solve? And if it is, that's usually what I do. I don't even try the algebraic. What's the best way to solve 21?
Isn't it algebraically? Like just
I think so, sure. What's the formula for the area of a circle? You need the general formula.
It's not 2 pi r. That's
the circumference.
Isn't it?
Are pi round or are they squared?
They're squared.
Pi r squared. And the reason I say that is because sometimes you can remember something ridiculous in order to remember something. Pi aren't squared, pi are round. So pi r squared is the answer, and the circumference, by the way, is the first derivative of that. If I take the 2 and stick it down in front, same 3 digits. Instead of pi r to the 2 power, it's 2 pi r. And these two, you want to have those on the tip of your tongue always. So, as long as I know the general formula, and they're telling me the area is 49 pi, what's r?
R7. So 14.
What's d? D is twice r. You want to tend to think of everything in terms of r. I mean, I know that circumference is pi times d, but d is just not a variable that you use very often. Circles and spheres are all about r. They're all about the radius. Everything is about the radius. So I never write circumference like this, even though it's correct. I just don't do it. It's not, we don't work with d most of the time. We are always working with r. Wow. Cupcake problem.
That would be it would be 34.
Okay, that's correct. And I'm betting that you did it in 2 steps, that you figured out the area of the rectangle and then figured out the area of the triangle.
Yeah.
Well, what is this figure, the total figure? It's a trapezoid.
Yeah.
Because this is parallel to that, and this is not parallel to that. That makes it a trapezoid. Well, there's going to be some more difficult problems where it's going to be easier for you to solve if you memorize the area of a trapezoid. What's the area of a trapezoid? Remember the formula?
Isn't it base 1 plus base 2 divided by 2 times height?
Uh-huh. And notice that that actually makes the problem a little harder, because now you have to figure out that this is 10. But as long as, if it were labeled 10, this would be the easier way to do it. It would be 10 plus 7 divided by 2, that's 8.5, times 4, which is 34. In other words, you can get it in one step by using the formula for a trapezoid. And notice that if the problem was slightly different, let's make that a non-right angle. Now, the only way we'd be able to get the area would be if we knew this total base. And if they gave it that as 10 or 11 or so, we would need that formula. In other words, let's say they gave us this base as 11. And that's the problem. what's the area of that figure? There's only one way to calculate it, and that's with the area of a trapezoid. You can't break it up into triangles. I could try to drop a vertical there and figure out what this distance was, but I would have no way of doing it. So the only way I would be able to get the area of this trapezoid is base 1 plus base 2 divided by 2 times 4. As opposed to this problem where you can break it up into a rectangle and a triangle. They're just as liable to give you the harder one. It would just be question 52 instead of 22. In other words, that's where all your hard problems come, in the 50s.
Oh, so it builds up, it doesn't just hit you with
that's what everybody has told me who has actually taken the test, and all of the practice tests I have are like that, where the first 30 questions are easy and medium, and the last 30 are medium and hard. You don't find a whole lot of easy questions in the 50s, but every now and then you do. And that's important because the most important thing to do is make sure you see at least all of the easy questions when you're taking the test. So you have to make sure you look at all 60 questions before you run out of time, just so you'll have a chance to make sure you do all the easy and all the mediums. If you happen to not get to one of the more difficult ones, that's okay. That is not nearly as costly as not doing an easy one. Doing an easy one is a gift.
Yeah.
What's the first step going to be here?
It would be to flip all the negatives to
the
other side.
Yes, exactly. So what does that give me? Those are positive, so I'll leave those there. And then that's positive, so I'll leave that there. So I'll put the b to the 4th down there. And then this 2 to the minus 2, I'll put up here, changing its sign. The a stays down there, and the c to the minus 2, I have to put another one and change its sign. Okay, now that's much more simplifiable.
Yeah.
What's the next step? What's the new numerator?
It would be...
What's the number part? Always do the number part first.
It would be 12.
What's the a part?
A. Just pure A.
Ah, we're done. Notice there's only one answer that has a 12a in it.
Okay.
In other words, you don't always have to do all of the math. Remember that when you're taking this test, is you're not trying to prove to anybody what your math skills are. What you're trying to do is answer the question properly in the shortest amount of time. That's the key. About 24. What's the first step?
I don't really know how to solve this, but wouldn't it be
what would your first step normally be in an equation where you have a fraction equals another fraction?
Cross multiply.
Right. However, this, and you could certainly solve the problem that way. That's going to work. It's just not going to work as easily as a shortcut. If my numerators are the same, what must be true?
The denominator has to be the same.
So I can short step that by doing this instead of cross multiplying, which becomes more complicated if I cross multiply. Whereas if I just set the denominators equal to one another, it's fine. Now, divide both sides by square root of 7, and I get my answer. X is equal to 7 divided by square root of 7. Well, that answer isn't on there. Let's rationalize it and see if after rationalizing it, we see our answer. How do I rationalize that?
Multiply top and bottom by square root 7.
Now I got 7 square root 7. What's the bottom?
7.
7's canceled. There's my answer. The other way I could have done it was written it 7 to the 1 divided by 7 to the 1/2. Subtract exponents. 7 to the 1/2, which is square root of 7. Either way. But the important thing on this problem is they about half of the 60 problems they're going to give you, there's going to be a shortcut for solving. There's going to be the long way, and then there's going to be the short way. If your life depended on it, you'd probably do the long way. But since it's a speed test, you want to take every shortcut you can see. And this was definitely one, they gave us a shortcut because they made the numerators the same.
All right.
So here's the quadratic equation that they're saying. How are we going to solve that?
Could you take square root of both sides? With that.
I don't want to do it before I get rid of this 3. So first, if I divide both sides by 3, then I can do it. In other words, that gives me 4/3 x. And now I can take the square root of both sides. But notice the problem. When I take the square root of both sides, I'm left with x on the left, but I'm also left with an x on the right, which means we've never solved it for x. The only time you're solving for x is if you have nothing but numbers on the right. In other words, this is not really a solution because I still have some x's on the right. So that's probably not the best way to go. What else can we do?
Plug numbers in.
You mean take the 5 answers and plug them all in?
Yeah, because...
Okay. That's certainly one way to go. There's an easier way still. What is one clear solution just by looking at it and looking at some of our answers? Can you figure out what x?
0.
0, exactly. So I don't have to plug in A, B, or E. I know those aren't right. I know that x equals 0 is one solution. Okay? And so the only other solution is either x equal 3/4 or x equal 4/3. Now, let's talk about something here. I can divide both sides by x. And that gives me that. And then, clearly, x equals 4/3. Well, what happened to the 0? I lost it because I divided both sides by a variable that might have been 0. And when you do that, you lose that solution. You don't get it. So that's not really the best way to solve this. It's not to divide both sides by x as your first step. The proper first step is to subtract 4x from both sides. Now you have 0 on the other side. And now factor out an x so that you have 3x minus 4. And now you have the product of two things equals 0. That means either x equals 0 or 3x minus 4 equals 0, which means x would be 4/3. So you immediately get these two solutions. But always remember that. That's one of the easy mistakes to make in math is dividing both sides of an equation by a variable. It's something you generally want to avoid. Because especially if it's a variable that you don't know whether it could be 0 or not. And this is a perfect example where if the variable could be 0, and that is one of the solutions, we completely lose it when we divide both sides by x.
All right.
So this is a better way to solve. All right, Mitch. I will. This is going to be our regular.
Yeah.
6 o'clock on Wednesdays. Let me make sure I have you down for next Wednesday at 6. I do. I'll speak to you then.
All right.
All right. Bye-bye.